So this is the introduction to Haskell. My name is William Fonseca. So first, Haskell support the basic arithmetic operation that are plus, minus, the product and the division operation. We have the operators like true, and, or, not equal, unequal, and the boolean values for true, false, and not. So the syntax is like we have in the image, like 2 plus 15 give us 17, 49 multiply by 100 give us 4,900. 1892 minus 1472 give us 4020, and 5 divided by 2 give us 2.5, and so on. Then we have the functions. Syntax are like this. We give the function name, the name of the parameters, and it's like the image. We have the function name, in this case that is min, the two parameters that are 9 and 10, and this function gives us the minus value of the two numbers. We have other examples that are min 3.4 and 3.2 that give us 3.2, and the max function that gives us the maximum value of the two parameters, that in this case is 101. Another example are the SOC9 plus max 54 plus 1 that give us 16. The SOC function give us the successor of the number, in this case is 10. The max value of 5 and 4 is 5, so 5 plus 1 is 6 plus 10 is 16. So in Haskell we have the same hierarchy that we have in mathematics. So we can do the same operation that we usually do with the math. We have two subcategories of function that are the prefix function and the infix function. The difference between these two that are that the prefix function define the function before the parameters, and the infix function goes between the first parameter and the second parameter. So to define a function, we set the function name and the parameter's name. Then we put the equal symbol, and then we set the expression. So for example, here we define a function named double that have one parameter x, and the function gives the double of the x value. In this other example, we have the double small number that double a number if is less than 100. So here we can see also the if expression. The if expression is a function, so it needs to return always a value. So we have to define the else part, and then we have the list in Haskell. The lists in Haskell are homogeneous. That means that are of the same type. So we have a list of numbers or list of characters, but we can have a list of numbers and characters together. And some operators of the list are the plus plus that append a list to another list. The the second one append a thing of of a list to the beginning of the list. So for this case we need to have the same type that the list that we going to see this later. And the last one operator we give is an infix function, and we give the an index, and it returns the value of that index in the list that we are going to see later. So some basic functions that we can do with the list that are defined in the Haskell language are the head function that takes a list and returns its head. The head of a list is basically its first element. So we have this example that we have a heap of 5, 4, 3, 2, 1, and it returns 5. We have the tail function that takes a list and returns its tail. So in other words, each job of a list head. So the tail of the list 5, 4, 3, 2, 1 is 4, 3, 2, 1. The last function is the same as the head, but it's going to return the last element of the list. So in the list 5, 4, 3, 2, 1, it returns the 1 value. And the init function is like the tail function, but give us all the initial value except the last one. And so we have some funny image that give an graphic explanation of how Haskell manage the list. So we have the head, the tail, the init, and the last. This is an image that can explain the functionality of the function that I explained. Some other operators that we have is the length function that gives us the length of a list. So the length of the list 5, 4, 3, 2, 1 is 5, and because have 5 elements. The null function checks if a list is empty. So if a list is empty, it returns true, otherwise it returns false. So it's recommended that use this function instead of comparing some variable to an empty list, because it's different have a list empty or a list of lists empty of a list that have two lists empty. So an example is null of the list 1, 2, 3 is false because that list have 3 elements. And in the second example we have the null of an empty list that is going to return true. The reverse function it's going to reverse a list. So for example, we have the reverse of the list 5, 4, 3, 2, 1. It's going to return 1, 2, 3, 4, 5. The take function give us the take function takes a number and a list, and it extracts that many elements from the beginning of the list. So in the example we have take 3 of the list 5, 4, 3, 2, 1, so we're going to return the 3 first elements of the list that are 5, 4, 3. We have take 1 of 3, 9, 3, that is going to return 3. And in take 5 of the list 1, 2 is going to return all the elements of the list, because we are going to take more elements than the one that have the list. And take 0 of some list is going to return an empty list. The drop function is like the take function, but it's going to drop the numbers of elements from the beginning of a list. So for example, we have drop 3 that is going to drop the 3 first elements of the list 8, 4, 2, 1, 5, 6. So we have the list 1, 5, 6. Drop 0 is going to drop is not going to drop any element because it's a 0. Drop 100 is going to drop all elements of the list 1, 2, 3, 4. The maximum function takes a list of stuff that can be put in some kind of order and returns the biggest element, and the minimum function returns the small. So the minimum of the list 8, 4, 2, 1, 5, 6 is 1, and the maximum of the list 1, 9, 2, 3, 4 is 9. The sum function returns a sum of the list. So the sum of 5, 2, 1, 6, 3, 2, 5, 7 is 31. The product is the same, but it's going to return their product. For example, we have the product of 6, 2, 1, 2 is 24. The ln function is usually used like a infix function because it's easier to read. So we have 4 ln 3, 4, 5, 6, and the function is going to see if the 4 value is in the list. So 4 ln 3, 4, 5, 6 is true because 4 is in that list, and 10 ln in the list 3, 4, 5, 6 is going to return false because 10 is not in the list. The Texas range is just a way to simplify the code. So instead of write a list like we have here in the example, instead of write a list of 1, 2, 3, 4, 5, 6 and go on to 20, we can write in the way that we have here. We say 1 point 20 and is going to return a list beginning in 1 and finish in 20, and works and also works with a list of shards. And here we have another example of Texas ranges that can look for some pattern in the list. So if we say 2, 4 and point 20, it's going to give us the all even numbers beginning in 2 and finish in 20. In this case, the syntax is like we have in the example, and we only can specify the two first elements of a sequence, and then we have the list comprehension. That is like a set comprehension in mathematics, so it's very useful to look to return a list. So in the example we have a list comprehension that is going to give us all the or a list of the numbers beginning in 1 and finishing in 10 but multiplied by 2. Uh, so in this other example we have a predicate that is going to give us some the predicate is going to give us some, how do you say, some limits to the list that is going to return. So for example, if we have the predicate that the values of the list that returns need to be bigger or equal than 12, so the list result is going to be 12, 14, 16, 18 and 20. We have some other examples. So the list comprehension of this expression is going to multiply all the possible combination between the two lists, in this case the list 2, 5, 10 and the list 8, 10 and 11. So that is going on is that we are multiplying 2 product 8, 2 multiplied by 10, 2 multiplied by 11, then we have 5 multiplied by 8, 5 multiplied by 10 and 5 multiplied by 11 and so on. In the other example we have the same expression, but we have a predicate that it says that it's going to return all values that are bigger than 50. So we have 55, 80, 100 and 100. In the other example, what we are doing is that we are going to take all the list in the list. So the lists are XS, and we are going to return a list of lists that have all even numbers of the list given. Then we have the tuples. The characteristics of tuples are that they don't have to be homogeneous, so we can have tuples of different types. So for example, we can have a tuple of a number and a character are denoted by parentheses and are restricted with the size. So for example, we have a pair that are a tuples of size 2, that in the first example we have a tuple of two numbers 8 and 11, and the first function is going to return the first element of the tuple, and the second takes is going to return the second element. This function only works with pairs tuples. Then we have the types. We need to remember that Haskell are type but not a strong type. So we can declare the type of a function also, because the function have types. So we can do like this, and we set the function name, we put this symbol, 2 points, and then we set the type of the parameters. The last one is the type of the function. So for example, here we are specify that the add3 function is going to take 3 parameters. All are the type of int, and it's going to return an int. Haskell have the type inference. That means that we don't have to specify the type of all the variables. Haskell can infer. So for example, we can just put a type of A and it's going to return char. The type of true is bool. The type of hello is a list of char that is equal to, say, a string. We have the type of a tuple is going to return the type of all the variables in that tuple, and the type of this function is bool because it compares two numbers or two equal data type classes. So the type classes are like a interface in the programming object orientation. So for example, the type of this function is that we have a variable called a that is part of the equal type class, and the equal type class is some class that can compare two values. The pattern matching is a way to specify patterns in some functions. So for example, we have the same function that take one parameter and return a string. So we have this pattern that if the parameter is 1, it's going to return the string 1. If the pattern match, if the parameter match with 2, it's going to return true, and so on. And in the last one, we have the generic case. So if is other value than 1, 2, 3, 4, or 5, it's going to return the string not between 1 and 5. The guards are a way to specify some. It's like an if-else in programming object like Java, and is going to see if the value of the parameters in this case is between 0 and 18.5 or 25 or 30, and the word give us some local variables. The let word works to declare some variable and they are local, so it's like the word syntax, but in this case we can use the variable specified in the let part to use in after the in word. So in the case of the function cylinder, we have two parameters, air and age, and we have two local variables that are side area and top area, and then in the in part we are using these variables. If we not specify the import, that variables are going to be local in the context that are using. The case expression is like the switch in language like Java or C++. So it's going to see if some value of the variable match with the one that we are going to define in the Potter part. So the syntax is case. We set the expression, then the word of, and then the pattern, and then the result. So for example, we have the head function that have a case statement. So we are looking if x is empty, is an empty list. So it's going to return the no head for empty list error. And if x is not an empty list, it's going to return the head. And it's all. Thank you.